Have you ever built an AI agent and suddenly found yourself completely unable to trace exactly why it made a specific memory leap or why it totally changed its strategy? Well, trust me, you are definitely not alone. Welcome to this explainer. Today, we're diving into Elume. It's a standalone Python library that promises to fix this exact headache by transforming messy, opaque AI memory logs into a highly structured, fully auditable cognitive substrate. Here's a quick look at our roadmap. We'll start with the opaque memory problem, dive into the deterministic kernel architecture, look at initializing immutable models, categorize the thought layers, cover evolving memory strategies, and wrap up with replay-safe auditability. Let's get right into it. Section 1. The opaque memory problem. We really need to escape the chaotic state of current AI memory logs. So think about standard AI memory right now. It usually relies on these really loose, mutable dictionaries. Data just gets overwritten in place, changes vanish into completely opaque logs, and mutations, well, they become entirely untraceable. If your agent learns something new and shifts its behavior, you might literally never figure out when or why that happened. But Elume approaches this entirely differently. It forces memory to become a rigorously typed, immutable foundation. It takes those loose dictionaries and replaces them with a completely auditable framework. To put it simply, and this is the core philosophy here, Elume turns agent memory from an opaque log into a replayable cognitive substrate. Under this system, memory is no longer just this passive storage bin where data sits around waiting to be pulled. It becomes a dynamic, highly testable process. Memories turn into predictable mathematical trajectories flowing towards stable attractors, and the whole thing is driven by self-modeling and pattern convergence. Moving on to Section 2, the deterministic kernel architecture. This is all about building that replayable foundation using post-state hashes. To stop those untraceable changes we were just talking about, Elume uses something called the deterministic replay envelope. This is managed by the Elume.envelope component, and you can think of it as a strict operation registry. It physically wraps every major cognitive action the AI takes. And by wrapping these processes, it produces stable post-state hashes. It's essentially putting a tamper-proof seal on every single thought process. And because of that tamper-proof seal, Elume offers developers an ironclad guarantee. Listen to this. If you provide the exact input, provide the identical mathematical seed, and match the platform fingerprint, Elume is mathematically guaranteed to generate the identical output hash every single time. No surprises, no random deviations. This is the holy grail of replay-safe cognition. You can actually finally test adaptive memory. All right, Section 3, Initializing Immutable Models. Let's see how we establish this typed cognitive state. When you're setting up an agent, you have to initialize the Elume.models component. This is our escape route from those messy dictionaries. You have to establish explicit, typed, and immutable records right from the jump. We're talking about everything from broad beliefs and strategies down to specific trajectories, basins, thoughts, priors, and even specialized metacognitive particles. Because you're initializing these as immutable records rather than just mutating existing data, you permanently preserve the cognitive state of the agent at every step. Let's make this concrete by looking at mental models. When you initialize explicit mental models, Elume categorizes them into 4 distinct domains: user, self, world, and task-specific. And each of those domains explicitly tracks 4 strict records: predictions, revisions, evidence, and status. So when your agent updates its understanding of a task, it doesn't just quietly overwrite an old log. Instead, it actively emits a brand new prediction or revision record. This guarantees a continuous, fully auditable trail of its evolving understanding. Which brings us to Section 4, Categorizing Thought Layers. Here's how Elume structures those internal cognitive events. You know how AI can sometimes feel like it has a jumbled random stream of consciousness? Well, Elume manages thoughts through the Elume.cognition component by slotting every single cognitive event into one of 5 distinct layers. You've got the sensory motor perceptual, conceptual, abstract, and metacognitive layers. Once categorized, these thoughts don't just sit there. They are thrown into deterministic thought competition, where they're evaluated using expected free energy-like scores. This mathematically guides what the agent focuses on. Now, to figure out exactly which thoughts win that competition across the different layers, the system relies on prior gated cognition. This is a gating mechanism that completely throws random sampling out the window. It works hand in hand with that thought competition to actively evaluate and intentionally guide what the agent thinks about next. So how do you, as the developer, actually control this gating? It comes down to 4 specific prior constraints: allow, block, boost, and suppress. By applying these constraints to specific thoughts, say in these sensor motor or metacognitive layers, you can strictly dictate the agent's focus. If your agent is getting stuck in some unhelpful repetitive loop, you don't just cross your fingers and hope it snaps out of it. You actively restrict it using these explicit prior actions. It's totally in your hands.
Section 5. Evolving Memory Strategies. How do we adapt without losing our lineage?
For developers wanting to genuinely adapt their agent's memory, here is the exact step-by-step. First, you start with your immutable strategy records, which are managed by the Elume.evolution component. Second, to actually improve the strategy, you apply concrete evolution operators. We're talking tools like the genotype jitter operator, the parameter toggle operator, or the uniform crossover operator. And then, the real magic happens in step 3. Instead of overwriting the old strategy, Elume generates entirely new immutable successors. This highlights the core mantra of the system: lineage over mutation. Because Elume strictly forces the generation of unchangeable records, instead of tweaking data in place, it prioritizes lineage above all else. It maintains a complete, unbroken evolutionary history. You will always know exactly how, why, and when your agent's memory strategy adapted.
And finally, Section 6. Replay-safe auditability. Let's make cognition completely testable. Take a second to consider the sheer scope of what is actually auditable here. Remember that deterministic replay envelope we talked about? Every single one of these complex cognitive and adaptive steps is wrapped right inside that operation registry. Calculating a curiosity score, embedding a belief, pulling an associative memory via Hopfield recall, running a thought competition, evolving a strategy, or stepping a self-model, every single one of these actions produces those stable post-state hashes. Literally nothing happens in the dark.
Here's a great example of why that matters. Normally, memory recall relies on passive, nearest match retrieval, just pulling the most similar query match. But Elume enables curiosity homing. This is a highly active process where the Elume.cognition component intentionally biases retrieval toward new information gain, guiding thought selection rather than just grabbing the nearest match. And guess what? Because the curiosity score is wrapped in a replay envelope, even this dynamic exploratory behavior is meticulously auditable. You can see exactly the mathematical reason why the agent found a specific memory curious.
By replacing messy, mutable dictionaries with a rigorously typed, immutable cognitive substrate, Elume finally allows developers to truly trace and trust their agent's thought processes. I really hope this explainer has illuminated Elume's powerful approach to memory dynamics. I want to leave you with one final, exciting question for your own agent development journey. If every cognitive step, from associative recall right up to strategy evolution, can be rigorously audited and replayed, what will your AI learn next?